Well, welcome back, everybody, to the second half of the programme. You'll be pleased to know it's only an hour until lunchtime, but I hope right now you are caffeine fueled and ready for the next couple of sessions. So I am pleased to introduce Morten Bilde, who is the Managing Director of AGCO. Morten has extensive experience in the agricultural machinery sector and currently at AGCO. Morten, take it away.
All right, thanks for the introduction. I will jump right to it for the sake of time here. I think a lot of the stuff that I'll be covering in my presentation has already been somehow addressed in the previous presentations, but I think I'm going to take maybe a slightly different angle to it. My presentation will definitely be less technical. Some may say that I may be taking a bit more of a blue-eyed view on the opportunities with AI rather than talking about the challenges. But the fundamental question that we are asking today is how can AI increase sustainability in farming? I think we can kind of all agree on a statement like that. When I think about sustainability in farming, I always come down to optimization of farming. I'm coming down to increase predictability in the decision making, and so on and so forth. Super simplified with this schematic here is kind of the optimization loop. The good thing about this schematic is that it really works at all system levels. So whether you talk about a full farm operation where you need to make strategic decisions, or you talk about a crop cycle within a production system where you need to make tactical decisions, or you even need to make very detailed operational decisions down to, say, the depth control of a planter. The optimization loop here is still kind of generic. So I'm kind of spelling this out to emphasize on where I see the two areas fundamentally where we see opportunities with AI. First and foremost, and that's definitely where we see the most applications already today, is using AI to generate information from data. Computer vision is kind of the obvious source, right? But also from other data sources. So basically generate new insights that enables decision making, either manual decisions or automated solutions. Which leads me to kind of the second area, which is using AI to turn information to decisions, right? Either by decision support to the farmer, or as a direct input to a closed loop automation system. So I'll be talking today about these two areas a little bit from an application standpoint, and then also kind of highlight how I see these opportunities also kind of reshape the product life cycles, and more so the product solutions that we are actually ultimately able to offer to our farmers and our customers. So for the insight creation here, I have just three quickly use cases I wanna share here to kind of emphasize on that, trying to map those against this workflow that really talks about how do you move from a specific problem to be solved to its solution. And the first example here, exact same use case as Alan was talking about just before. We want to optimize the quality of the grain that we harvest with our combines. To do that, we take images of the clean grain, raw RGB images. With AI, we process those images and classify the particles in the images and determine and classify certain quality parameters of interest. That information, those insights, are then directly fed into the control system to optimize the settings of the combine. The second application here, also as Alan alluded to, exact same application again. This time, the use case is a forest harvester. The objective here is to optimize the quality of the forage, of the silage, using camera, using AI to, exactly like what Alan was explaining on the class solution, determine the CSPS score. In contrast to class, we don't feed it into the control system. We present it as information to the operator, enabling the operator to make the adjustments himself. Now, you probably sense a little bit of a hidden theme here on the reusability of hardware. And I want to touch on that a little bit, because this is one of the big game changers I see, more from a scalability and business standpoint. Over the years, we have been very limited in our opportunity to really scale the implementation of technology within agriculture, because we are fighting low volumes on our individual vehicles. The technologies that we provide are very often, say, one-trick ponies, meaning that we have a piece of hardware for a very specific application. With some of these AI solutions, we can continuously build new applications on top of the same hardware. Like in this example, where we are reusing the exact same hardware between the combine and the forest harvester. We are even behind the scenes reusing a lot of the development tools, the training pipeline for the AI model, so on and so forth, which really allows us to deliver solutions faster and also in a, say, more cost-efficient way, not just for us, but also for the customer at the end. But that reusability doesn't really stop there, because not only can we reuse specific components between different applications, different machinery, so on and so forth, we can also, without moving the sensor, if you will, we can also continuously build applications on top of the same hardware, even on top of the same raw data that we are collecting. So this example, we use the same camera mounted the same location on the combine, taking the exact same images, like what we are processing in real time on the combine to optimize the combine itself. But instead of just have that use case, once we invested in that collection of data, we want to collect the data and then develop additional functionalities in the sense of interpreting new information from this exact same data point, right? So this is just one example, taking the images from the combine, process them in the cloud, detect weed seeds, and by doing that, be able to generate weed population maps, which can then be used not on the combine, but downstream for targeted weed control. Okay, so that was just a few examples on the generation of new insights. Coming back to this simplified schematic of this optimization loop, elaborate a little bit to show also how this work in an automated setting. So adding a control system there in the loop, meaning that we generate insights, we feed that to a control system, and the control system makes the decision. The operator, the farmer per se, interact with the control system, not to define the detailed settings, but to provide some more, say, tactical guidance for the control system, like optimization strategies and those type of things. This is kind of the loop that we see in some of these automated applications that we often refer to as AI solutions, right? I think targeted spray is one of the well-known ones. Another well-known application is autonomy, in the sense of environmental perception, obstacle detection, which is an enabler for autonomy. Right? So the control system itself is not AI per se. It's more traditional model-based control system. But because of the generation of new insights, information, we can really scale the automation solutions that we can develop. However, like I said, the farmer operator of a specific machine is still entitled to interact with the control system and provide strategic settings and those type of things, overall targets to the control system. So scaling automation opportunities is great, right? But it also comes with this kind of inherited paradox, if you will, described in many ways over the year. I think this example from the early 80s is probably the, at least to my knowledge, the first one where it was kind of articulated as in an article stating that the more advanced the control system is, the more crucial the contribution of the human operator. Meaning that the more we automate our systems, often the more complexity we add to what remains for the farmer, the user, the operator, right? I'm not going to give specific examples here, but I think we can all think about solutions where we are at least in danger of adding more complexity than what we remove. I'm highlighting this because this is another, say, the next fundamental area where I see a lot of opportunities within AI, and that is simply to assist the user, the farmer, in making some of those more tactical decisions, basically helping in operating a automation system or a manual system for that matter. So especially using AI agents, we see opportunities to kind of develop a new way to interact with our solutions, assist the farmer, but also as a way to include other data sources in our solutions. Not only do we envision that these AI agents will advance in their capabilities, moving all the way towards reinforced learning control systems. But even more interesting is that we can apply these agents following kind of the system architecture of what we're dealing with. So basically have a agent hierarchy to support the farmer with different, well, decisions ultimately, right? So from the more strategic decisions at the farm level to the more tactical decision within a crop cycle or a specific, harvesting system, and then down to the more operational decision on optimizing very specific functionality within a specific vehicle or machinery. Now, that's of course one super important transformation that will influence how our product offerings will look like going forward. Another fundamental is simply the nature of the life cycle of AI solutions that are also fundamentally different from, say, traditional products, even software products. And we can talk about agile software development, but even that still follows kind of a sequential value stream from research to development, implementation, and maintenance. And when we talk about agility, we really talk about the product increments and the speed in which we can follow these processes. As we talk about AI products, that's kind of the fundamental difference there, is that we have more of a continuous life cycle. And I would even claim that it's not just a continuous cycle like illustrated here, because all of these elements kind of operates in parallel. So we continuously collect data, we continuously train model, we continually evaluate models, we continually deploy, meaning that ultimately we continuously research and implement and deploy and maintain at the same time. So our AI product solution becomes more of almost like a living organism within its own skin. Now, what I want to highlight with that is more on the product definition side of things, because this is what offers opportunities for us to redefine what a product is, right? A product going forward is not just a static functionality. It's something that will continually evolve in the hands of the user. So we can deliver smarter product designs. We can also act faster to new requirements, continuously learn and adapt. But maybe what's most important, what I find most intriguing, is that we can really start to truly co-create with our customers, right? I think we've talked about co-creation for decades, right? But when we talk about these AI type of products, co-creation is not something we add on top. It's really inbuilt in the actual value stream of these products. So what I want to touch on here at the end is one very first initial approach to motivate co-creation, product co-creation that we have built and launched. It's called Innovation Hub. It's an inbuilt feature in our GeoBird off-board platform for weight line optimization. It's a free of use platform for everybody, so feel free for those who are not already a user to connect. As a subset of this tool, we have this feature we call Innovation Hub. What that is really a place where we post new products, not ready products per se, but early prototypes, concepts, even ideas that we have not even developed yet. So we do that to motivate farmers to join us, if you will, and help co-create these solutions. Already from the ideation phase, we want to understand what are the most important problems to solve even before we start solving them, right? Today, this platform is solely used for off-board web applications and those type of solutions. But where we want to take this is that we want to build on this, community within the product solutions that we also embed within our physical machinery. Again, because we have this continuous evolution of those products, they are never static. We, even after launching a feature, we still need the feedback from the customers and kind of have the customers to add context to that feature. We have many means to collect raw data from our machines and sensors, right? But what we are often missing is the context around the data. And what we enable with these type of tools is to kind of nudge our users of our solutions to provide some of that context that we can then synchronize with the raw data. And that's one of the things that really accelerates our development and bug fixing when we experience issues or we run into new field conditions that we have not seen before and all those type of things. So I think with that, I just want to wrap up quickly, kind of summarizing that I do believe that AI will accelerate this transformation to more sustainable farming, not just because of the say product opportunities themselves, but also because of this inherited opportunity to co-develop with our farmers. Short term, as also seen today, several use cases generating new insights that we haven't had access to before. Is probably the biggest game changer that also enables automation. Here in the nearest future, I do see a lot of opportunities for having more AI augmented interfaces to assist our users in actually using the technology even. More long term, I talked about this agentic AI and advancing that to ultimately reinforced learning, starting to, at least for some applications, replace the more traditional model-based control system. And then last but not least, AI development. Our AI development processes, the inherited nature of those will provide opportunities to change the products that we can deliver and even kind of move from the product space to more the service space in what we can support to our farmers. So open to any questions if there is still time.
Well, thank you, Morten. That was a really fascinating insight into how these products are being developed, and I'm sure you're going to be inundated with people giving you suggestions of what to explore next. That bit about the context, I think, is really important, isn't it? These solutions are only viable if they work in real world scenarios. So really fascinating. Thank you. So the question here is on the development. Technology has high costs for development and adoption and support. How can UK agriculture cover the investment required from slim business margins? So we know that UK farming businesses are very low profitability. Or is it a case that UK agriculture can't afford not to adopt these technologies?
So that's a really good question, and that's probably what have say slowed down the implementation of smart farming, like we have talked about for the last, I don't know, 20, 30 years, right? I do believe that AI as part of the solutions is a bit of a game changer. I explicitly talked a bit about this reusability of hardware. Hardware is one of the biggest cost driver in the solutions and the products we develop. And the more applications, the more problems we can solve, the more solutions we can deliver that builds on the same fundamental hardware, ultimately builds on the same data point that we collect, the better stand our business cases also for us and, well, for the farmer ultimately, right? So if we only implement a sensor and collect data for a single application, then that application needs to carry all that cost. But the more we can reuse, the better. I think that's one of the big fundamentals, and it of course requires us as developers to say adapt as well, in the sense of being much more even much more software focused and less hardware focused. Right?
Thanks, Morten. I think that nicely flows into a question from Mike, who's saying that farmers have a lot of access to data, but they aren't using it fully. So how can we encourage them? How can we keep them engaged in this journey without kind of befuddling them with and overcomplicating things?
Yeah. So I think it's about closing the loop, right? Because we for many years we have just delivered information, and I know I talked a lot about generation of additional insights using AI, but what really matters is that we can close the loop and deliver a solution, not just a data point, right? I mean, for how long have we developed providing yield maps? I mean, 30, 35 years or so, right? The value creation from those yield maps today is still limited because it's just a single data point. We have kind of failed to close the loop and provide really, actionable solutions.
Thank you. And just time for a couple more. So farmers want a free choice of technology. How do we ensure that all these AI systems can work together and that farmers aren't just asked to use one particular system?
Yeah, so I think it's one of the I can only speak to kind of AGCO side of the business here, but we are very keen on this mixed fleet strategy, in the sense that we don't want to create a closed ecosystem with our solutions. We want to create an ecosystem on which we can integrate with a mixed fleet of machines and solutions, because ultimately that's what's out there with our farmers, right? And that strategy is really inbuilt in all the solutions that we develop. One of the reasons why this forest harvester solution that I mentioned is an aftermarket kit and not an integrated solution within our specific vehicle, as an example.
Thanks, Morten. And Danielle's just asking if you can share the web link to your innovation hub, please, which sounds like it's a real fountain of useful information. So if you wouldn't mind putting that in the chat, that would be really appreciated.
I'll do that.
Thanks so much. And thank you again, Morten, for that really insightful presentation.